Good morning, my name is Heriberto Acosta.
And my name is Orlando Ferrer.
Welcome to the first edition of the Broader Participation in Data Mining's Innovators series of web interviews. Today is the first of what will be a regular series of interviews featuring a diverse group of people from data science and its related fields.
First of all, we want to take this opportunity to thank Sofia Stolberg. She's the co-founder and co-owner of the co-working space Piloto 151. We want to thank her for allowing us to stream from here. Piloto 151 is a co-working space located in San Juan, Puerto Rico. For more information of the facilities, please visit www.piloto151.com. So today we have the pleasure of interviewing Adam Cheyer. He's the co-founder and VP of engineering at Viv Labs, and previously co-founder of Siri. Welcome, Adam. Adam, before we start the interview, can you tell us a little bit about your background, what motivated you to go into this field, or how did it come about?
Sure. So I've been interested in artificial intelligence pretty much from the earliest times. I'm interested in making machines easier to use and smarter to use. Sorry, the screen just switched. So I would say I really got interested when I was an undergraduate at Brandeis University. It was a liberal arts school, and I took a lot of classes on psychology and linguistics and neuropsychology and computer science and philosophy, and all of my interest was trying to figure out how the miracles that we are as people, how we work and how we do everything that we can do. And so over 20 years, 25 years, I've been working in various fields of AI, and here I am today.
Great. So can you briefly describe what a regular workday for you would be like today?
Sure. So I'm a morning person. I usually wake up around 5 o'clock in the morning. I'll get up, get ready. I leave by 6. Usually, and I take a train. My work is about an hour from my house, and people say, what a horrible commute, but I love it because it gives me 1 hour every morning and every evening of my own time. So I have a desk, Wi-Fi, etc. So in the mornings, it's really quiet time to catch up on email, to plan my day, to kind of take notes, or to do things that I just am interested in or working on. Once I get to the office, so I have a small company right now, about 20 people. So there's many more interactions we have, but not too many meetings. Most of the days we are all in a room and we're using chat systems to type back and forth to each other in various topic rooms. So it's pretty quiet actually in a room full of people. We usually have one 15-minute stand-up meeting where we all get up and say, this is what we're doing, this is what we've accomplished, this is what we're working on, and whether we're blocked with some issue. That's one big part of our engineering practices. Mm-hmm. We have a release schedule of about every 2 weeks. So about once every 2 weeks we have a planning meeting where we review how our current release was, see if we can improve anything for the next one, plan the next release. But that's pretty much it. So other than 15-minute stand-up, a bi-week, every other week planning meeting, occasionally I'll be in a meeting for product features where we'll talk about how something should be done. Mm-hmm. But a lot of the time I just sit at my computer and code all day, and I love to do that.
Great. We love it too. Is this Viv Labs you're talking about?
Viv Labs, yes.
Oh, I'm sorry, Viv Labs. What can you share about Viv Labs? What do you do, and what is it all about?
Sure. So we're pretty stealthy. We have not yet launched, but I can give you an idea. So in a sense, what we're doing is really trying to look for what I consider the next major interface paradigm. So if you think about the web, when it first came out, every business in the world now needed a website because it was a great way to get out their brand, to sell their content, their transactions. It was a new channel for them compared to what they were using before, maybe catalogs and things like that, mail order. And then mobile came around. Apple invented the iPhone.
Right.
Now businesses needed either a website and either a mobile app or at least a mobile website, because so many people were using these mobile devices. And so we asked the question, what's the next major paradigm that every business in the world will need to connect to? What's the new channel for them to sell their wares? And we believe that it's not just going to be a single thing, but there's a lot of innovation going on at the endpoints. So there are wristwatches coming, smart watches, glasses with Oculus VR, virtual reality. There's smart home innovations with TVs you can talk to. You spend a lot of time in your car and hands-free devices. So what we see is that voice and conversation, conversational interaction, would be a natural way that people interact with each other. We think this will become increasingly important going forward with computers, and they fit. A voice interaction is important for every modality, whether it's talking to your wristwatch or talking to a remote control to a TV, or you're hands-free in your car, or you're maybe in a virtual reality. So, and yet there's no place that every business in the world can go to connect their content or transactional services and to play in all of these arenas, the watch, the car, the TV, the phone, etc. So Viv Labs is going to provide really the marketplace, almost the app store,
Right.
where any company can take whatever they do, their domain expertise, their services, their content, plug in, and Viv will take them to all of these places where a website and an app are not appropriate. So you can think of it a little bit like Siri, what Siri does on the phone.
Right.
And say, I want this, I want that, do this, book a restaurant, buy a movie ticket.
Right.
Have one interface to 20 services from a phone.
Right.
Imagine Viv that will provide one interface to every service.
Yep.
From not only a phone, but from many, many different endpoints. And that's what we're doing at Labs.
Something like a global API.
Exactly. So it's really like in the same way Google was the interface to the web. That's where people go, the gateway to all the web pages. And maybe Apple App Store or the iPhone itself is the gateway to the world of mobile apps.
Right.
We want to be the gateway to all of those services and content that have websites, have an app, and we will take them to different places.
Very good. And now, so it's very in line with the Internet of Things paradigm that we're moving forward in recent times.
Yes, I think that's accurate.
Can you talk a little bit about sometime maybe in the past about some hard problem that you had to work on and how you overcame that problem and found eventually a solution for that?
Sure. So I'd say, I was working in a research laboratory before starting Siri at SRI International. It's the famous place that invented the computer mouse. It was the first node on the internet. It's a wonderful place.
Mm-hmm.
And we had built a prototype of Siri, but it worked pretty well for 1 or 2 users, but it was kind of a toy scale system.
Right.
And you could say things like find a French restaurant in Palo Alto, and it would do that, and call out to services. This is great. But then we loaded in real-world data at scale. So we loaded in 20 million business names and all of these geographic names. And we realized that pretty much every word in the English language is a business name. And so, we had a system that was working really great. We added in this huge vocabulary store, which we now needed to do fuzzy matching across and still try to understand the sentence. And I remember typing in the most basic command of Siri was start over, which would kind of bring the system to a reset state. And I type in start over, and it said, looking for businesses named Start in Over, Mississippi. I'm like, what just happened? And in order to, with all of this vocabulary and all of the ambiguities present at such scale, it took us several months to kind of climb back out of that real-world data, that real-world problem, where we couldn't just artificially, design the system as we liked. And when you put it in with all the craziness that are business names and, why is it, WHY, like why? It's a city in Arizona, and on and on and on. And so once you added all of that ambiguity and complexity, I'd say that was one of the hardest technical challenges we did. And it's kind of a lesson. Many times entrepreneurs and even researchers, they can design ideas in sort of a confined space, a little design of their own design, and they can cut the corners they want to, load in the vocabulary sets they want to, or what have you. But when you have to put this in front of real people, facing real data at scale, that's when you really, you've done all this innovation to have your algorithms, to have your technology, but the real innovation starts when you have to take it from your prototype to reality. And that, I think, just comes through persistence and work and innovation, just creating and working through problems.
Okay, yeah, it's totally a different ballpark when you try to scale things to the real world. So since you talked a little bit about Siri, what was the original idea behind it? How much can you say about it, the origins, or what was the original motivation for it?
Sure. So I did a talk at AAAI conference about a year ago. I think some of you may have been there. But in this story, people saw Siri, and it came out by Apple, and it seemed to come out of nowhere.
Right.
We didn't have a Siri, and now all of a sudden we had a system. So the AAAI story was really the story behind Siri. And what many people don't realize is that the story goes back, my story, my version of Siri, goes back longer than people expect. So I started in this talk in 2011, and I showed a version of Siri, and I said, this is great and wonderful, the version that you know on the iPhone. Let me tell you about this great version we had in 2010, where as a startup, we did something that was so cool, it made Steve Jobs call the office unannounced 2 weeks after we launched. That version was really cool, and it did many things that weren't in the 2011 version. And if you think that was cool, let me tell you about the version we had in 2007 that did all of these incredible things that never made it into the version we released.
Right.
And I kept going back, and I went to 2007, and then to 2003, and then 1999, and then 1993, which was many years earlier. And in the beginning, I went to 1986 when Apple came out with a concept video called Knowledge Navigator. You can find it on the web. And it wasn't a real system, but in it they showed in '86, remember, before the internet, before iPads, before Siri, they showed a system that was very futuristic, where you really had a professor had a tablet that you could talk to, and there was an animated assistant who knew your life and could help you achieve tasks and could help you find information on the internet. So for me, I was very inspired by some of this early concept work done by Apple in 1986, and then built early prototypes, research prototypes in the early 90s. Before I ever saw a web browser, I was imagining a world where you would have an assistant you could talk to, and building a world, and you'd have collections of thousands of services around computers all over the world that were working together collaboratively on behalf of this user. And then the punchline from the AAAI talk was, as we go back and back in time, and in some ways each system got more advanced. Well, certainly, of course, they were also much weaker in many other ways. But you go back to 1986, and I say to the audience, you can actually figure out what day it was in that concept movie. It was set in the future, and what day is it in the future? And you can look, there's a calendar on the desk where it shows a day in a month, and then later on you can get a year reference. And it turns out that the 1986 video was actually set 24 years later in the future, within 2 weeks of the original launch of Siri by Apple. So Apple had the concept video, Apple released it with a 24-year release cycle, and only missed the date by 2 weeks. So that was part of the story for the talk.
It's pretty incredible,
Yes.
either way.
Where do you see this technology, or the technology you're researching, in the next 10 to 20 years?
Well, you know, there's been a lot of focus and about the AI boom. AI is really in the press right now, and you have people like Elon Musk and Bill Gates and Stephen Hawking talking about how in 20 years computers, you know, AI will have reached human-level intelligence because of Moore's law and everything. I don't, you know, actually agree with that. So it's not quite as sensational as the story they're telling. But I see the many years of work that have been gone into many of the innovations we're seeing today. And it has been improving. It gets better every year and more useful and more scale and smarter. But it is, for me, somewhat linear. So if you look back, you say 20 or 30 years, I say, well, we had AI systems 20 or 30 years, and they were somewhat like the AI systems we have today. Today they scale a little bit you know, more. It's used by more people. It can do more things, but it's incrementally smarter. It's not exponentially smarter. And I tend to be of the view that you know, even though machines are improving exponentially, you know, at Moore's law, software, our ability to create smarter software, is kind of increasing linearly. You know, we haven't changed a way to accelerate exponentially the way we create and the way we think. So in my view, AI in 20 to 30 years will be better than it is today, probably by the same level that it was better going back 20 or 30 years. It'll be more widely deployed. It'll be more used. So, you know, we didn't have search engines, which is a form of AI. We didn't have mapping systems that could plot routes between any 2 points on Earth, you know, through Google Maps. That is AI. You know, so there are big advances in 20 years. But on the other hand, in the last 20 years, we didn't create a system that can have feelings. We don't have a system that has self-awareness, that has consciousness, that has really kind of this decision-making. And so I don't think we made any, you know, much progress along those dimensions in 20 or 30 years. I don't expect us to make significant progress in the next 20 years along those dimensions either.
Do you think, is there a hard or interesting problem that you think AI or machine learning should be currently focusing on right now?
Well, I think our ability to scale AI and to understand AI has improved, and so now the opportunity is to apply this into many, many more places than we have in the past. So I think for data science and machine learning in general, there's huge advances to be made just by taking machine learning and saying, well, let's try applying it to this problem. Let's try applying it to this problem. And really making it much more pervasive. So I think there's a huge, you know, practical benefit to be done just from harvesting a lot of the learnings and compute power and applying it to new areas, rather than, you know, we're really moving from an age where everything was kind of hardwired by programmers to now some problems, you know, rather than writing in all of the rules and having a human think of what those rules are, you can pose the problem, say, here are the inputs, here are the outputs, have machine learning techniques to learn those rules automatically, to mine patterns in data, and now the question is, what do you apply it to? So I think that's one very broad, interesting area. In terms of advancing AI, there's a lot of focus on deep learning. today and neural networks.
Mhm.
I think deep learning and neural networks are great, but there's so much media and buzz about them, it's a little bit overhyped. So if you think about it, in machine learning, anything that moves the needle, the smallest percentage is a huge advance. And deep learning moved it a few notches up, which is incredible. But if you think, if you told public, yep, we can now solve certain problems 3% better than before, it's incredible. They're like, 3%? That's it? Right? And so there's a little bit of that in data science. And it'll continue to get better, but it will take time. What I think the biggest opportunity in AI as a whole is mixing three things together. Certainly the pure machine learning is useful, and it can be used to learn some things very, very well. I think there's a role, and this is some of the approach we're taking at Big Labs. Humans still need to be involved in helping teach machines. It's nice to try to apply machine learning just over data, but there are some things that just won't be learned, can't be learned. And if a human with their common sense and knowledge can teach the system and help it in this collaborative way, that's where I think there's real opportunity. Because today, that teaching usually comes from a few programmers. But if you could harness the world, the collective intellect of the entire world, to have many, many, many millions of people teach an AI system, that becomes interesting. I mean, even a human baby is taught by the world and taught by parents. And you could argue that if you only had a baby and you locked it into a stimulus environment where they don't get to interact with people, it won't learn as much, right? So I think a huge opportunity is how do you harness the collective intelligence of the world to be able to teach these AI systems, not just having the systems on their own running over data. So those are what I think two opportunities in this field are.
A lot of the students most of these questions were submitted by high school and college students, and a lot of other stuff of the questions they asked us was, what courses or what research labs would you recommend them, or would you recommend them to focus on if they want to work in AI, machine learning in the future?
Sure. So I've been out of school for a certain amount of time now, so I'm not going to tout any particular schools or programs or classes. I will say that my undergraduate, I went to Brandeis University, was liberal arts. It was not a technical school. So I have a Bachelor of Arts in Computer Science, which is, I think, quite different. But it helped me bring this multidisciplinary approach to a technical field. As I said, I studied linguistics and philosophy and psychology and neurobiology and many different, as well as computer science. And I think that gave me a more rounded perspective. So it's a little bit counterintuitive that, well, if you're going to do machine learning, you need to just study math at a technical school. I actually think the end goal is not to just learn machine learning, because that's one piece of the equation. I think, for me, AI, it's to try to understand how we work, and you can do that from many different angles and get insights from many different angles. So I would say, if you want to go into machine learning, yes, study machine learning, but only as a complement to a more multidisciplinary approach. I did my graduate work at UCLA, which I think is an excellent school. I got a lot out of it, and it really let me, the difference between graduate studies versus undergraduate is you had much richer, deeper, project-based classes where you would build systems and you had the time to really get in and try to solve hard, I won't say real-world problems, but harder problems than an undergraduate class where you're kind of taught thing. So I'm a huge fan of how do you get into artificial intelligence or computer science. Is find a question that you're really interested in and try to build it and see what you can do. And then once you've gotten to a certain point, you're like, huh, well, that works a little bit, but not really. What have other people done? And you really need to kind of drive yourself by your own curiosity and give a lot of focus and interest. The last thing I'll say about this is probably the most influential class that I ever took, and something that still, surprises me and I use today and inspired me, was a class on logic programming. So I learned a language called Prolog, which is almost dead in many ways, and it's kind of what I'd call a good old-fashioned AI, GoFi approach. It's a language where there's lots of symbols and structures and reasoning, and not a lot of numbers or math, and it's not Java. So it's kind of fallen out of fashion. But when I was learning computers, after a while, everything kind of seemed the same. I learned this programming language and that programming language and this programming language. When I took logic programming, it was like a magic trick. They showed this incredible thing. You're like, okay, wow, that's amazing. How does that work? The system's able to understand natural language. Usually when you understand the behind the scenes of how a magic trick works, you're like, oh, is that all it is? It's kind of a trick. Not so good. With logic programming, when you understood how it worked, it was even more of a miracle. And so I came out every day from this class. The teacher's name was Tim Hickey. Changed my life, and it was the most different way of thinking about computer science that I had ever seen. It was so different from the procedural, just tell the computer what to do. You didn't do that in logic programming, and it just blew my mind. So that's something I've taken with me all these years, and I feel like many of the computer science programs have lost this, and it's really the magic that taught me computers can think in ways that you can't even imagine, and it's been a big inspiration.
Absolutely, yeah, I agree. It's a completely different way of thinking, and following along that same line, do you have any advice or any ideas of ways we can model common sense, knowledge representation, and reasoning in a computer?
That's, of course, a huge field in itself.
Absolutely.
I think there's some really interesting work going on in kind of mixing probabilistic and symbolic work. When I worked at a project called Kalo. It was the largest machine learning project in U.S. history with $250 million of funding and maybe 400 researchers from the best universities in America. One of the most interesting projects there, they built something called PCE, Probabilistic Consistency Engine. So you could think of it kind of like a rule-based, logical engine, but it had probabilities, and it was reasoning about multiple hypotheses, multiple worlds at a time. So Kalo, which was an assistant for office automation, kind of for office workers, might say, hey, I think you need to go to this, it might say something like, Peter can't make the meeting on Tuesday, I think you should move it. And you say, well, why? And it says, well, I think Peter is the project manager of this project, and I think this meeting is about this project, and usually the project manager attends the project meeting, and then I would say, oh, Peter's doesn't even work on the project. And it would go, he doesn't? Tilt. And it was like this giant switch to, well then, who is the project manager for that project, and etc. And it would kind of shift based on facts that were given, and balance all of these hypothetical guesses with a rule framework, and then be able to adjust its beliefs in real time. I thought that type of work, so it didn't scale very well, but if it could be made to scale, to solve huge problems, I think it would be a very interesting infrastructure. So I would say that the work that I'm most excited about in representation is where you blend kind of more of a logic-based approach with probabilistic models.
Very good. So, if you are familiar, do you have an opinion about any recent online courses that have been coming out about the different AI topics? You know, these massive open online courses. Are you familiar with them, or do you have an opinion on them, or any comments at all?
So certainly, you know, I'm friends with Daphne Kohler and Andrew Ng, who are both former Stanford professors, and they've started classes like Coursera and there are other kind of large-scale online learning communities. I think they absolutely play a role and are a great tool as part of our education. I don't think they will completely replace you know, universities as we know it, but I do think there will be a change. Right now, the costs of universities are so expensive. Many of the lower and middle tier ones, it's very hard to justify their existence and the benefit they bring for the costs. So I do think in the coming years they will play an increasing role, although, you know, top universities will continue to exist.
Do you think, and you covered this a little bit previously when we talked about how the field does not necessarily grow exponentially as the same as hardware does, but would you say that we can expect to see personality and ethics in AI systems during our lifetimes or in the near future?
Well, personality and ethics are different than kind of self-aware or conscious systems. So one could argue that Siri has personality, but I would say, as one of the people who worked on Siri, it's not a self-aware, conscious, really thinking system.
Right.
So I do think personality can play a huge role in the systems, an increasing role in the systems that we build. They will become more familiar with us and be more tailored to our tastes. And being able to show that through personality, I think, is a great thing. In terms of ethics, I think, you know, all technology can be put to good uses or bad uses. I don't think it's a question of AI versus any other computer software. I mean, there are computer viruses that I think you might say violate ethics at some level. And so for me, AI, you know, we always have to be thinking about ethics as we create the software and figure out what the implications are. So yes, there will be an increased focus on both personality and ethics going forward in AI. However, the stories that I see and the predictions that I see about computers becoming as smart as humans or self-aware, I do not believe that will happen in my lifetime or my son's lifetime. I do believe it's worth thinking about, because in the same way that you might think about time travel or you might think about extraterrestrials, you know, it's quite likely there is life somewhere in the universe. It's a very big universe. It's quite likely that there may be intelligent life somewhere in the universe. It would have profound implications if we ever came into contact. So it's interesting to think about it, but I sort of feel like, and I believe it's probable that life exists. Just in the same way, I think it's probable that AI will eventually be able to achieve, maybe I'll call it sentience. However, I feel that the likelihood in the near term, meaning decades or centuries, that we're going to encounter extraterrestrial life or computer life, I think is very slim. So I don't think we have to be afraid in a day-to-day basis of either of these.
Absolutely, yeah. I mean, us as computer scientists and engineers, we may have a perception that maybe the general public does not have about what AI really is, and we do need to take that into consideration. And
yeah. So my message would be, I think there are huge opportunities in the near-term coming years for AI to help us solve problems that we have not been able to solve previously, and I think a lot of practical benefit. I think there's very, very small chance for the fears that we have. We're not even at the beginning of creating systems like this, so I don't think we have to worry.
Absolutely, yeah, and I agree 100%. All right, so given the attention recently on the Internet of Things, do you think there's a right combination between intelligence in the cloud and intelligence on a device, on a physical device?
Yeah, I do. I have opinions about everything. So it used to be that a lot of the intelligence lived with us on our laptop because we were not as connected before the internet. And then, some of the larger companies came and they brought such convenience and power that now my email doesn't live on my laptop anymore. It lives in the cloud. Everything, my shopping history lives in the cloud, etc. So I believe at some point, and I think people are willing to trade privacy and convenience. But at some point, I do think there will be a swing back a little bit more towards privacy, and that's when the home becomes a little bit more connected. So imagine a home where you have your own personal cloud, and that becomes the place that you should be able to maintain and store your own data, your own personal preferences, your own histories, from medical history to shopping history to everything. And the home becomes a nice firewall, a nice hub, a nice cloud, connect all of your devices. And of course, you still want to go out to the global cloud, and access things that are not stored in your home. But for me, all of those preferences and histories really should be yours, and you should only dole them out to services out in the world as you need it in trade for very specific things, but you should have control. Today, all of those services are maintained out there. So for me, the perfect architecture I would want is a hub in my house with my data privacy vault, a lot of house services, which are pretty dumb in certain ways. There's not a lot of intelligence in each device. Those devices should be screens, input and output mechanisms, not huge processing mechanisms. I think we'll have a smart processing mechanism in the house, and of course there'll still be external clouds with rich servers, but those privacy account issues should live in my side of the world, not out there.
Well, Adam, thank you so much for your time. Before we go, do you have any advice for college students, either at undergrad or grad level, that you can give them if they want to continue and if they have an interest in this field?
I would just say we're living at a unique time in the history of humankind. The compute power becomes almost free, and it becomes this palette that as an artist you can create almost anything. If you're a computer scientist, almost anything you dream of can be brought to reality, and that's incredibly exciting and something that never existed 50 years ago. I mean, the ability to dream of something and not only create it, but then to bring it to the world pretty much for free at mass scale to hundreds of millions, billions of people. So we're living at an unprecedented time. If you're interested in computer science, I think it's only going to become more important, more exciting, the possibilities will become even more endless. And I can't imagine anything really more exciting to do at this point in time. If it were hundreds of years ago, I might give a different answer and say maybe woodworking is absolutely, or the printing press, that's where things are. But today, computer science, and in particular, the data and usage that you can get, I think is an incredible tool and palette that no generations have ever had access to before. So I've been loving this time, and I'm excited about the future. I think we need more bright minds to help shape it.
I agree. Well, thank you very much for your time. Where can people find, if they want to find more information about yourself or your current projects, what you're currently working on? Can you direct them to any place in particular?
Sure. So they can go, for me, they can go to my website. It's adam.cheyer.com, CHEYER. And that'll have the news of the different projects that I work on. With my current company, we're pretty much in stealth mode. Our website is viv.ai, VIV.ai. You won't find much there yet, but soon we think we will come out with something that I think for AI people and hopefully for the rest of the world they will find exciting and interesting.
Perfect. Thank you very much. Thank you for the viewers. If you have any ideas for us, we're going to have more people to interview in the upcoming future. You can email us at bpdmprogram@gmail.com with your suggestions. Thank you.
Excellent. Thank you. Bye.